Okay, so we're dealing with volume and height of cylinders and cones. So the volume of the cylinder is 1,536 times pi centimeters cubed. What is the height of the cylinder? So the first thing we have to remember is how to find the volume of a cylinder, and then once we have that equation, we can use it to work our way back to the height. Well, if you'll remember, finding the volume of a cylinder is similar to, in some ways, finding the volume of a rectangular prism. When we found the volume of a rectangular prism, we remembered that it was length times width times height. That gave us the volume of the space inside of there. And what that is length times width. So the first thing we're doing is finding the area of the top part, and then we're simply multiplying that by the height, right? So if we use the same process over here, we're going to have to find the area of this part and then multiply it by the height. So we've got our formula. Volume is equal to pi r squared. Where does that come from? Well, the formula for the area of a circle is pi r squared. And then we simply multiply that by the height. And we've done the same thing as we did here. We found the area of this and we multiplied it by the height. Now we're given the volume. We know that that's 1,536 pi. And that is equal to pi times the radius squared times the height. Well, we also have been given the radius. The radius here is 8 centimeters. So we're going to have 64 because we're squaring that radius and multiplying it by pi and times the height. That's going to give us 1,536 pi is equal to 64 pi times height. And now we can just use some basic algebra to get this taken care of. So on this side, we'll divide by 64 pi. We want to isolate the h. We want to get this all by itself. We simply remove the other portions of that term. So we're going to divide by 64 pi. Well, that means we have to divide by 64 pi on this side. And then you just punch that in your calculator. Now, we don't have to punch in the pi because the pi cancels itself out. Pi divided by pi is 1, so those cancel out. We just divide 1,536 by 64, and we get 24. So the 64 and the pi cancel out, leaving us with h on the other side. So we know that the height is 24. In this problem, we have a similar situation, only this time we've got a cone. The volume of the cone is 96 pi centimeters squared. What is the radius of the base of the cone? And for this one, once again, we've got to remember, how do we find the volume of a thing? Well, as we said last time, we would find the area of the top and multiply it by the height. Well, this time we have a cylinder, and we know that to find the volume of a cylinder, we decided last time that we were going to do pi times radius squared times the height. But in this case, we've got a cone. And when it comes to the cone, what we'll wind up doing is actually taking 1/3 of that value, because there's less, right? There's not the same amount as there would be in a cylinder. There's less. So we multiply that whole thing by 1/3. And let's see what values we can put together. We've got 1/3 times pi times the radius squared, which we don't know. So the radius squared we don't know, but we do know the height, so we can plug in 8 right there. And then we can do a little work here, and we'll find that 8/3 is what you get when you multiply 8 times 1/3. 8/3 pi times the radius squared is equal to the volume of this cone, which is 96 pi. And then all we have to do is divide on this side to get rid of our pi here, and our 8/3 will divide by 8/3 pi. Those will cancel out, and so over here we'll have to divide by 8/3 pi. The pi's cancel out, we divide 96 by 8/3. And that is going to give us 36. 36 is equal to r squared. We're almost done. Now we don't want r squared, we want r. So what have we got to do? We've got to take the square root of r squared. And to keep it balanced, we have to do that to both sides. So we wind up with the square root of r squared, which is r, and the square root of 36, which is 6. R is then equal to 6. And you're done.